For decades, scientists have relied on a kind of cosmic instruction manual, the Lambda Cold Dark Matter Model, better known as CDM. Think of it as the universe's operating system. It's the model that told us how galaxies form, how dark matter keeps them from flying apart, and how mysterious dark energy accelerates the expansion of the cosmos. It's the model that's won Nobel Prizes, fueled textbooks, and served as the foundation for nearly everything we thought we understood about existence itself. In short, it's been our cosmic Bible. But here's the catch: what if that Bible is already outdated? What if the very code we use to describe the universe is running on old software missing critical updates? Enter the James Webb Space Telescope. Better known simply as Webb, launched only a few years ago, Webb is humanity's most powerful eye on the cosmos. With its massive golden mirrors and infrared vision, it can see deeper into the universe than any telescope that came before it, deeper than Hubble, deeper than any ground-based giant. And the deeper you look into the cosmos, the further back in time you're peering. Light takes time to travel, so the galaxies Webb observes aren't snapshots of the present. They're cosmic fossils, images of what those galaxies looked like billions of years ago. At first, astronomers were excited. This was the big moment. The plan was straightforward: aim Webb at the furthest reaches of space, peek into the so-called cosmic dawn, and finally see what the very first galaxies looked like. In theory, this would confirm the CDM model yet again. It would be a victory lap, proof that our understanding of the early universe was solid. But that's not what happened. Instead of seeing faint, baby galaxies struggling to form, Webb found something much stranger. It spotted massive, bright, fully formed structures in the earliest chapters of the universe's history. Galaxies that looked too mature, too dense, too massive to exist so soon after the Big Bang. It's like opening a time capsule, expecting to see the fingerprints of cavemen and instead finding skyscrapers, airplanes, and smartphones. Astronomers were floored. Some of the earliest objects Webb detected appeared to be 10 times more massive than our theories said they should be at that point in time. According to the CDM model, galaxies take billions of years to gather enough material to grow that big. But here they were sitting comfortably in the universe only a few 100 million years after its birth, and that's just the beginning of the weirdness. Webb also detected complex structures in regions of space we thought should be quiet and uneventful. According to our cosmic storybook, there was a time known as the Dark Ages of the universe, a period right after the Big Bang, before the first stars and galaxies flickered to life. During this era, the cosmos was supposed to be dark, empty, and boring. But Webb's sharp eyes suggest that this picture might be wrong. Instead of peaceful nothingness, it found signs of structure, activity, and even massive objects forming way earlier than expected. Suddenly, scientists were left scratching their heads. Could it be that our most trusted model of the universe, the one that's carried us for half a century, has been missing something huge? Let's pause here and get technical for a moment. The CDM model says the universe is built on two invisible foundations: cold dark matter and dark energy. Dark matter provides the cosmic scaffolding, pulling galaxies together with its hidden gravity. Dark energy does the opposite, pushing the universe apart, accelerating its expansion. Together, these forces are supposed to explain why galaxies look the way they do and why the cosmos is growing faster over time. But here's the issue. According to CDM math, the early universe simply didn't have enough time or material to create the galaxies Webb is spotting. To build them, the universe would have had to use up all the ordinary matter available, and even that wouldn't have been enough. The numbers just don't add up. So, scientists are asking uncomfortable questions. Maybe CDM isn't the full story. Maybe it's only a rough sketch of a much stranger, more complex reality. Some even whisper about the possibility that the universe didn't have a neat beginning at all. What if those distant galaxies we thought were early aren't early at all? What if there's something else, entirely evidence of a deeper structure, or even another universe bleeding into ours? These aren't fringe ideas anymore. Some of the brightest minds in astrophysics, including Nobel Prize winners, are starting to entertain them. And that tells you just how seismic Webb's discoveries really are. Imagine being a scientist who's built your entire career on CDM for decades. Every experiment, every telescope, every observation seemed to confirm its predictions. Then suddenly Webb pulls back the curtain and reveals a cosmos that doesn't fit the script. It's exhilarating but also terrifying. It's like discovering that the map you've been using to navigate the world is upside down, and yet this is how science progresses. Every time we think we've nailed the ultimate truth, nature surprises us. In the early 20th century, physicists thought they had everything figured out until Einstein's relativity rewrote space and time. Later, quantum mechanics shattered our idea of determinism. Now, perhaps cosmology is standing at the edge of its own revolution. What Webb is showing us isn't just a set of quirky outliers. It's a systematic challenge to our most sacred assumptions about the universe. And if these findings hold up, and so far they seem to be, it means we may have to rethink not just galaxy formation, but the very nature of time, space, and origins. The big question now is, what exactly are these mysterious objects? Are they really galaxies? Are they some new class of cosmic structures we've never imagined before? Or are they telling us something even more radical, that the Big Bang model itself needs rewriting? One thing is certain, the universe just got a whole lot more interesting. But to understand why this is so shocking, we need to rewind nearly a century. Because long before Webb's golden eyes ever unfolded in space, another telescope pointed at the stars changed everything we thought we knew. That's where our story turns next, to a man named Edwin Hubble, and a discovery that set the stage for the greatest cosmic mystery of them all. To understand why Webb's discoveries are shaking the very foundation of cosmology, we need to rewind the clock almost a century. The year was 1929, and a man named Edwin Hubble stood at the Mount Wilson Observatory in California, pointing his telescope toward the heavens. What he found didn't just rewrite astronomy, it flipped our entire understanding of the cosmos upside down. Until then, many scientists believed the universe was static and eternal, a kind of cosmic museum where galaxies were fixed like paintings on a wall, but Hubble's observations told a different story. By studying the light from distant galaxies, he discovered that nearly all of them were moving away from us. Not only that, the farther away a galaxy was, the faster it was receding. This was the birth of modern cosmology. It meant space itself was expanding, stretching like taffy being pulled in every direction. And here's the kicker, this expansion had no center. No special point you could call the middle of the universe. No matter where you stood, it looked as though everything else was moving away from you. Stand on Earth, and you're the center. Stand in another galaxy, and you're the center there too. Everyone gets a front row seat in their own personal universe. It sounds almost like a trick of perception, but it's very real. The expansion of space means galaxies aren't actually flying through the void like rockets. Instead, the very fabric of the universe is stretching, carrying galaxies along with it. Imagine dots drawn on a balloon. As you inflate it, the dots move farther apart, not because they're traveling, but because the surface itself is expanding. But here's where things get mind-bending. This cosmic expansion isn't slowing down, it's accelerating. The farther a galaxy is from us, the faster it's speeding away. That discovery alone earned scientists a Nobel Prize in 2011. And it also introduced one of the greatest mysteries in all of physics, the invisible force called dark energy, which seems to be driving this runaway expansion. Now, let's put ourselves in Webb's shoes or mirrors. Imagine standing on Earth, looking outward through this extraordinary telescope. What do you see? A universe where galaxies aren't just drifting apart, they're racing away at incredible speeds. At a certain distance, known as the Hubble sphere, galaxies are receding from us at the speed of light itself. Beyond that boundary, galaxies are technically moving away faster than light. Wait, what? Faster than light? Isn't that impossible? Doesn't Einstein say nothing can break that cosmic speed limit? Here's the nuance. Nothing is actually moving faster than light through space. Instead, space itself is expanding, stretching the distance between us and those galaxies so quickly that it outpaces light. It's not a spaceship violating physics, it's the fabric of reality playing by its own rules. Now, here's where it gets even stranger. You'd think that if galaxies are outrunning light, we'd never be able to see them. After all, how can light from something moving away faster than light ever reach us? But in a twist only the universe could pull off, we can still see some of those galaxies. Why? Because the Hubble sphere itself isn't fixed, it's expanding just like everything else. Over time, light that was once trapped in the race can catch up to us as the universe stretches. It's as if photons are riding an endlessly lengthening escalator, eventually reaching our eyes after billions of years. Of course, this doesn't mean we can see forever. There's a hard boundary called the observable universe. Think of it as a giant bubble around Earth, about 92 billion light-years wide. Anything inside that bubble, we can detect at least in theory. Anything beyond? It slips away into the cosmic unknown, forever invisible to us. And if you look right to the edge of that bubble, what do you find? Not stars, not galaxies, but a faint, ancient glow called the cosmic microwave background radiation, CMB. This is the baby picture of the universe, a snapshot taken when the cosmos was only a few 100,000 years old. It's the afterglow of the Big Bang itself, stretched into microwave wavelengths by billions of years of expansion. Now here's another jaw-dropper. The most distant galaxy we've ever detected is nicknamed Jade's GSC 140, spotted by Webb in 2023. The light from this galaxy began its journey when the universe was only about 290 million years old, a mere toddler on the cosmic timeline. When we look at it, we're not seeing it as it is now, but as it was billions of years ago. But here's the tragic part. That galaxy, as it exists today, is lost to us forever. Over time, it's drifted beyond our observable universe. No matter what, it has become a giant cluster of galaxies, or perhaps something even stranger, its light will never reach us again. In a very real sense, Webb gave us a fleeting glimpse of a galaxy that is now cosmically unreachable. And yet, beyond that edge, there's more, much more. Entire realms of stars, galaxies, maybe even civilizations, sitting in parts of the universe we'll never see. The observable universe is just our bubble, centered on Earth. For an alien civilization 50 billion light-years away, their bubble would look completely different. We're all trapped in our own cosmic horizon. This brings us to one of the deepest philosophical questions of cosmology. Did the universe really start from a single point? The classic Big Bang story paints a dramatic image of singularity, infinitely dense and infinitely hot, exploding outward to create everything. But that's not quite accurate. If the universe is infinite now, and much of the evidence suggests then it's always been infinite? The Big Bang wasn't an explosion from a point in space. It was an explosion of space itself, happening everywhere at once. Galaxies didn't appear in one location and spread outward like cities on a map. They emerged everywhere simultaneously, across an already infinite stage. This is why the CMB glow comes to us from all directions. It's not a spotlight shining from one corner, it's the afterglow of a birth. That happened everywhere at the same time. For decades, this framework has been enough. It explained the cosmic background. It explained galaxy formation. It explained the expansion we still observe today. But here's where Webb enters the story again. When astronomers pointed Webb at the farthest reaches of the universe, essentially trying to peek as close as possible to the Big Bang itself, they didn't see what theory predicted. Instead of fragile, forming galaxies, they saw mature, massive, luminous objects that had no right to exist yet. Instead of empty darkness in the cosmic dawn, they saw complexity and structure. And that's why the CDM model is wobbling. Because if galaxies were forming everywhere, instantly and faster than possible, maybe the Big Bang story isn't as complete as we thought. So here we are. The Hubble sphere tells us there's a limit to what we can see. The observable universe reminds us that most of reality is hidden. And Webb is suggesting that even the small slice we can observe doesn't fit the script, which leads to the next big question. What exactly are these impossible galaxies? Are they really galaxies at all? Or are we staring at something new, something beyond the boundaries of our imagination? That's where we turn next into the heart of Webb's discoveries, and the rise of the ancient giants that have scientists questioning whether the Big Bang itself needs rewriting. By now, the James Webb Space Telescope has given us more than just a new view of the universe. It's given us a problem. A big one. When Webb set its golden mirrors toward the deepest corners of space, astronomers expected to see fragile, flickering galaxies just beginning to assemble. These would be cosmic toddlers, small, faint collections of stars barely held together by gravity. According to our standard CDM model, galaxies take billions of years to grow large and bright. The early universe simply shouldn't have had enough time or enough raw material to create anything substantial, but Webb's images didn't show toddlers. They showed giants. Astronomers began spotting dozens, then hundreds of galaxies that were far too massive, too luminous, and too structured for their age. Some were estimated to be 10 to 100 times larger than models predicted should exist. At that point in cosmic history, these galaxies weren't supposed to appear until billions of years later, long after the so-called cosmic dawn. One study, published in the Astrophysical Journal, stunned the scientific community. Researchers identified 87 potential galaxies that could have existed only 200 to 400 million years after the Big Bang. To put that in perspective, if the universe were a 24-hour day, these galaxies appeared within the first 5 minutes of midnight. The problem? According to CDM math, that's impossible. When the numbers don't add up, let's break this down. Galaxies form when clouds of gas and dust collapse under gravity, sparking the birth of stars. But this process takes time, lots of it. First, matter has to cool and clump, then small stars form. Slowly, these stars merge into larger structures. Over billions of years, galaxies grow into the magnificent spirals and ellipticals we see today, but Webb is showing us galaxies that appear to have skipped the line. They're not fragile, half-formed clusters. They're fully operational star factories. And they got there impossibly fast. Even more bizarre, in most galaxies today, only about 10% of available gas turns into stars. The rest remains as raw material, hanging around in interstellar clouds. But Webb's data suggests that in these ancient galaxies, it wasn't 10%, it was 100%. Every atom of gas collapsed into stars, leaving nothing behind. That's not just unusual, it's supposed to be impossible. Our physics says galaxies don't work that way. Not ever. Dr. Haojing Yan, one of the study's lead authors, put it bluntly. Even if a few of these galaxies are confirmed to be real, it means we seriously need to rethink how galaxies formed. In the early universe, are they even galaxies? At this point, some scientists began to wonder, maybe these aren't galaxies at all. Maybe Webb has uncovered an entirely new category of cosmic objects, something we don't even have language for yet. After all, when Hubble was first launched, it found things that were initially thought to be stars but turned out to be whole galaxies. Could Webb be doing the same on an even deeper level? If they are galaxies, then our models of galaxy formation are wrong, fatally wrong. If they're not galaxies, then we're dealing with a new kind of structure that could rewrite the rules of physics itself. Either way, the old script doesn't fit anymore. The Big Bang in question now. Here's where things get really uncomfortable. If galaxies this massive existed only a few 100 million years after the Big Bang, then either the universe is older than we think, or the Big Bang story is incomplete. Right now, the official timeline pegs the universe at 13.8 billion years old. But these giants suggest that, unless galaxies can grow at superspeed, maybe the universe had a head start we don't know about. Some cosmologists have even floated radical ideas. What if the universe didn't have a beginning at all? What if what we call the Big Bang wasn't the start, but just a transition from one cosmic state to another? These aren't wild, fringe speculations anymore. They're being discussed at conferences, published in papers, and debated by some of the brightest minds alive. Webb's data is forcing the conversation. The Nobel-level Shock won Nobel Prize-winning astrophysicist even suggested that Webb may have stumbled onto evidence of another universe. That's right, our telescope might have peeked not just into the early universe, but into a neighboring reality bleeding into our own. Sound crazy? Maybe, but remember, 100 years ago, the very idea of an expanding universe sounded insane too. Science has a habit of turning today's madness into tomorrow's textbook. A cosmic identity crisis. Think about it. For half a century, CDM has been our North Star. It explained nearly everything. The cosmic microwave background, the structure of galaxies, the acceleration of expansion. It was elegant, clean, and reliable, but Webb has thrown a wrench into the gears. Suddenly, the neat story of a quiet cosmic dawn followed by gradual galaxy growth is gone. Instead, we see a universe that looks messy, fast, and unpredictable right from the start. For astronomers, it's both thrilling and terrifying. Careers have been built on CDM. Whole fields of research assume its accuracy. If it crumbles, then entire libraries of cosmic theory may need to be rewritten. But that's also the beauty of it. Science thrives on cracks in the narrative. Every time a theory breaks, a deeper truth emerges. Relativity replaced Newtonian physics. Quantum mechanics shattered classical determinism. Now perhaps Webb is nudging us toward the next great revolution in cosmology, the road ahead. So, what comes next? Astronomers are now racing to confirm whether these ancient giants are truly as old and massive as they appear. Webb's instruments are incredibly precise, but data can be tricky. Distances can be miscalculated. Brightness can be misleading. A galaxy that looks ancient could, in theory, be something closer but disguised by dust and light distortion, but so far the evidence is piling up in favor of the impossible. And if even a handful of these galaxies are confirmed, the implications are staggering. It would mean the Big Bang model, as currently written, is incomplete, and that leaves us staring at an even bigger question. If the Big Bang doesn't tell the whole story, then what does? Webb has shown us that the early universe isn't what we thought. It's brighter, denser, and more mysterious than anyone imagined. But if galaxies aren't playing by the rules of CDM, and if the Big Bang isn't the neat beginning we thought it was, then maybe we're standing on the edge of an even deeper cosmic mystery, one that suggests the universe itself may not have a beginning at all. That's where we head next into the most radical, mind-bending ideas emerging from Webb's discoveries, a universe without a starting point, and the possibility that our cosmic story is far stranger than the Big Bang ever allowed. A universe without a beginning? For decades, the Big Bang has been the ultimate origin story. It's the moment we imagine the universe bursting into existence, space, time, matter, energy, all exploding from a single, infinitely dense point. Called a singularity, it's dramatic, it's elegant. And it has shaped our collective imagination from textbooks to TV shows. But what if that story is incomplete? What if the universe never truly began at all? That's the radical question. Webb's discoveries are now forcing us to consider cracks in the origin story. Let's revisit the problem. According to the CDM model, the early universe was supposed to be simple tiny galaxies slowly taking shape, stars igniting cautiously, matter clumping together in predictable ways. But Webb shattered that expectation. Instead of cosmic toddlers, it found ancient giants galaxies that were massive, dense, and fully formed just a few 100 million years after the supposed Big Bang. This doesn't just poke holes in the CDM framework. It challenges the very timeline of cosmic history. If galaxies can appear so quickly, either the universe is older than we think, or our understanding of its birth is fundamentally flawed. Some physicists are even asking, what if the Big Bang wasn't the beginning, but just one chapter in a much larger, ongoing story? The infinite universe idea. One possibility is that the universe has always existed in some form. Instead of exploding out of nothing, maybe it has gone through endless cycles, expansion, collapse, rebirth over and over again. This cyclical universe model has been around for centuries in philosophy and myth, but now it's creeping back into serious scientific discussions. In this view, the Big Bang we talk about might not have been a beginning at all, but a bounce, the latest reset in an eternal cosmic rhythm. Imagine the universe breathing, expanding outward, then contracting inward, then expanding again. Webb's observations of rapid galaxy formation could be evidence that the universe already had structures in place before. The bounce we call the Big Bang. Another idea is the infinite multiverse. According to some versions of quantum theory and string theory, our universe might be just one bubble in a vast cosmic foam. Bubbles pop into existence all the time, each with its own physics, laws, and timelines. If that's true, then the Big Bang wasn't the birth of everything. It was just the local start of our bubble. And here's where it gets even stranger. Some scientists believe Webb might actually have caught hints of this. A Nobel Prize-winning physicist recently suggested that the bizarre Galaxies Webb is spotting could be evidence of a neighboring universe overlapping with ours. Imagine two soap bubbles colliding, their surfaces blending for a moment. What we think are impossible galaxies might actually belong to a different cosmos bleeding into our field of view. Time without a beginning now. Let's really stretch our imagination. If the universe has no beginning, then time itself may not be linear in the way we think. Our everyday intuition says time has a past, present, and future like a line with a clear starting point. But what if time is more like a circle with no true beginning or end? This isn't just philosophy. Some physicists, including those working on quantum gravity, argue that time could be emergent, a property that arises only in certain conditions, like temperature does. In that sense, asking, when did the universe begin, might be the wrong question altogether. To put it another way, maybe the universe didn't begin. Maybe it simply is the human shockwave. Of course, these ideas don't just shake physics. They ripple into philosophy, religion, and culture. For centuries, humans have sought a clear origin story. Whether it's the Genesis narrative, the Big Bang, or other myths of creation, we crave a beginning. It gives us a sense of order, a sense of purpose. But what if the truth is messier? What if the universe doesn't owe us a neat beginning at all? For some, that's unsettling. If there was no singular moment of creation, then what does that say about meaning, about destiny, about our place in the cosmos? For others, it's liberating. A universe without a beginning is a universe without limits, a canvas of infinite possibility, unbound by the constraints of a single origin story. Webb's role in the revolution. None of this speculation would be on the table without the James Webb Space Telescope. With its infrared vision, Webb has pierced deeper into cosmic history than any instrument before it. And instead of confirming what we thought we knew, it has given us paradoxes. Galaxies that shouldn't exist. Structures that shouldn't be there. Light that seems to belong to a universe stranger than our models allow. In science, paradoxes aren't dead ends. They're doorways. Every major leap in physics began with something that didn't make sense. Newton couldn't explain Mercury's orbit. Relativity was born. Classical mechanics couldn't explain blackbody radiation. Quantum mechanics was born. Now cosmology faces its own paradox. Webb's galaxies that shouldn't exist. This could be the beginning of the next revolution. The future of cosmic theory. So, where do we go from here? Astronomers are now gathering more data, refining Webb's measurements, and preparing for the next generation of telescopes. At the same time, theorists are working overtime, sketching out bold new models of the universe, models that might accommodate Webb's giants without breaking physics entirely. Some propose modifying the role of dark matter. Perhaps it clumped more quickly than expected, accelerating galaxy formation. Others suggest tweaking dark energy, changing how it drove expansion in the early universe. And then there are those who think we need something far more radical. A new physics that transcends the Big Bang altogether, whatever the answer. One thing is certain, the next decade of cosmology will not be boring. The story isn't over as we close this chapter. Remember this, science is not a static set of answers. It's a living, breathing process of discovery. For years, the Big Bang and CDM model were the final word. Webb has reminded us that there is no final word, only deeper questions. So, what did Webb really show us? Maybe galaxies forming impossibly fast. Maybe hints of another universe. Maybe Evidence that time itself has no beginning. We don't know yet. And that's the point, because the most exciting thing about the universe isn't what we understand, it's what we don't. And thanks to Webb, the cosmos just became stranger, older, and more mysterious than we ever dared to imagine.